Hello and welcome here from the Bau in Munich, the leading trade fair for architecture, materials and systems. We're here at a hotel room, Novotel, right next to the Bau. 18 halls of architectural systems and materials. Now today we'll dive into an AIA accredited presentation on quality views, energy efficiency and daylight. This program is sponsored by Keller Minimal Windows. Keller Minimal Windows is a company that's based in Luxembourg. It stands for innovation and craftsmanship since 1980. The company is part of the Valvitas Group, international family-owned company group with about 2,000 employees worldwide. Keller Minimal Windows is based in Luxembourg, 47 employees in in about 60 countries, over 35 partners and 47 employees. Now, Keller Minimal Windows manufactures the profiles in Luxembourg. They're cut to size and delivered to their international partners to the project sites, where then they're installed by certified and trained partners. Now, the range of products include sliding systems, double window sliding systems, triple pivot doors, as well as fixed elements. Now, all of these are NFRC certified, which is important in the North American market, and they are also AAMA certified as well. Something important to mention is that these systems have been tested in the actual sizes for water and air structural tightness. So there are not small sizes extrapolated to the sizes that will be installed. They actually tested the real deal that's used in projects, because we want to make sure that we don't have any water penetration or too much air penetration. Just to give you a few inspirations of the project types that Keller Minimal Window works on internationally, mostly high-end residential, but there's some high-end multifamily projects as well. Now let's dive in. So this presentation today will be on quality views. We'll talk about health and comfort benefits. We'll talk about the requirements for quality views. And we follow the LEED certifications system, as it is a sophisticated, established system internationally. We'll talk about related strategy. Whenever we work with high window-to-wall ratios, it's extremely important to consider the energy efficiency, but also the comfort for the occupants. Now, what are quality views? Like I mentioned, we will define quality views by the LEED certification, but when we look at a few pictures here, they're very, very much. Now, quality views and views in general inspire us humans, and they support health, well-being. This view in particular is Van Gogh's view from his chalet in the Netherlands. So it inspired him to paint a lot of incredible pictures that look somewhat like this. But when looking at these different pictures, we know that there is a wide range and variety of views connecting the occupant really with the outdoors. The latter really connecting, making the inside and the outside one. Now, quality views are extremely important for our well-being. We aim to really give the occupant a connection to the natural outdoor environment, to provide environmental cues from diurnal changes, from rhythms, and a disruption of these rhythms can have significant health issues, can cause significant health issues. Now, a study commissioned by the California Energy Commission looked at quality views, daylighting, and worker performance, and found that the performance increased for the workers that had quality views. It mattered most the amount, so the size of the view, but then also if there was any vegetation in the background. And they actually found out that there was an increase of visual memory, 9 to 16% of the tested subjects. And then also they looked into long-term and short-term memory, and the participants with views just performed a lot better. Now, in days of working from home office, it's extremely important to consider that it's not just the well-being, but that also the productivity of the workers that work from home should be considered. Now, we will follow the requirements based on the LEED requirements, and LEED states that we have to have a direct sight line for 75% of the regular occupied floor spaces. We have to have a direct view to the outside. Now, these are the living rooms, the bedrooms. Now, not regular occupied floor spaces would be the mechanical room or the stairway, beneath the stairway. And in this case, we beautifully see this. We have these direct views. We also need to have more than one sight line. So it's not enough to just have an opening right in front of us. We want to be able to pivot about 90 degrees and have a view that direction as well. Is associated with benefits to our well-being as well. And this would be an example of these two 90-degree views. Now, another requirement is that we meet at least the following two of the three categories. We have to be able to see flora, fauna, the sky, movement, or objects that are at least 25 feet in distance. So it's not enough to have a big view, but a building right next to our building where we just look at a wall, that's just not giving us enough relief. And we can kind of see here where we really create that environment and feeling. We also have to have an obstructed view located within the distance, and that view has to be at least further apart, further away 3 times than the opening. So if we have a floor to ceiling opening that's about 10 feet, then we want that object to be at least 30 feet apart. The third category is the view factor, and it's essentially rated by the angle of the view. We have to have a view factor of at least 3, which, when we think about it, it's between 1, the least, and 5, the best. The further our view turns apart, the improved the well-being is. And so at 3, LEED considers this to be a quality view. Now, there's a step-by-step guide based on LEED to follow in building design to create quality views in a project. Now, we know that most of our projects, single family, may not go for LEED certification. Also, there's a LEED for Homes program, but architects in general, designers, builders, just following these categories and step-by-step guide, it could just be helpful to create quality views for occupants in buildings that may not be certified, because who wouldn't want a quality view? Now, one, it's important to consider the orientation, the shading. So where are the views? Where's the solar heat gain coming from? That is obvious. We want to design for transparency. We want interior views. We want transparent partitions. In this case, we see here, this is an office room in this case. This is open. We have a direct sight line, and this is closed up, which we see a lot more in older offices. So the people right behind there don't get that direct sunlight access. So this would be a red flag for a project that will want a LEED credit. We also want an open floor plan, which of course in homes is something that we need to consider. So that the daylight really flows throughout the building. And the core consideration is the fourth topic here. Core consideration essentially means if we have an office complex, we want to move the private offices to the center, to the core of the building, so that all the people working in cubicles on the exterior side of the building will actually have direct access to lighting versus only a few privileged offices. Identify regular occupied spaces. We talked about that. 70 rooms that are 75% or more occupied. And then we want to identify direct sightline, which we mentioned earlier. So we want a clear image to the exterior, which we obviously have here, which is acceptable. We can also have ceramic frit or digital print being used on the glass in order to mitigate heat gain, which can be an issue if we use a lot of glass in projects, but in this case it still maintains that crucial sightline. Now, what's not allowed to be used is ceramic frit digital print covering the entire surface, because at that point we're not connecting well with the exterior, which we really are focusing on. Now, permanent interior obstructions, we mentioned that earlier. It's that next step to make sure that not more than 25% of these obstructions exist. And then consider design changes if those exist. Now, once the last two steps, essentially, we assess the view quality and conform compliance. And this is just helpful for an architect working on a project, a designer working on a project, to essentially go through that step-by-step program and then just really check those boxes, list all regular occupied spaces, what are the floor plans, what are the sections, the elevations look like, so that we have a good understanding that these occupants will have the direct access of daylight and views. And then last but not least, we go through these view types that I mentioned earlier: multiple sightlines, we want exterior features, no obstructed view, and we want to assess the view factor as well. So that's just a summary of the previous slides, and just a good habit to go through to check those off. Related strategy. So whenever we have a lot of glass being used in a project, we want to make sure we manage daylight, but of course we want to enhance daylight as well. We don't want too much, we don't want too much glare. We want to manage the energy, the heat gain, the heat loss, and we, more importantly, want to make sure that those occupants have a comfortable environment. Now, starting off daylight, just kind of setting the mood a little bit to this, in this case, a study where these students don't have direct access to daylight. In this case, we have an office where there's direct access. It just is a different feeling just looking at these two pictures. Looking at this restaurant, there's some openings, but if I'm sitting right in the back of this room, I don't feel connected to the exterior at all. So having something like this, in this case, some sliding doors, some fixed, really being in the core of the building, I still feel connected. I still feel that daylight, and that makes a big difference. And then, of course, there is the scenario where we really want to eliminate any barrier. We want to be inside, but we want to feel like we are outside. This may be the case in institutional projects, such as universities. In this case, it is a bar at a country club where they want the people that walk by, just invite them to get in and take a seat, but still feel like they're outside. Now, the next crucial topic is to consider daylight, natural daylight versus artificial light. So for our well-being, it's extremely important to experience this vitalizing, rich daylight that we get from the sun, versus artificial light that really comes short of that. So what we see down here is essentially ultraviolet ranges ranging from about 250 nanometers all the way to 950 nanometers. What this means is we cannot see this. The human eye can see light starting at 400 nanometers all the way to 700. Anything beyond is infrared light causing heating. Anything below is, some of it is for the birds. Birds can actually pick up ultraviolet light. We can't. Now, this is the spectrum we can see, and each nanometer wavelength has a color. So if we see reddish, the end of the day, the sun is going down, that is because the solar radiation, the wavelength is about 600 to 650 nanometers. This is what we need for well-being, this vitalizing, rich light. Now, when we have fluorescence lights, particularly energy-saving lighting, falls really short of this. Now we can see the vitalizing daylight, we can see the fluorescence light, how it falls short of it. There is a peak at 600 nanometers, at 500, and at 550. The human eye sees most sensitive in that range of blue, and this is why they're also spiking these areas here. But it falls rich of it, so it really is not what we need to be healthy and to feel good. Now, the daylight and benefit. Again, we didn't come up with this. We follow LEED guidelines, and LEED considers certain intents and benefits. Connecting building occupants with the outdoors for health reasons, for well-being reasons, reinforcing the circadian rhythm is something very important, and the reduce of electrical lighting from an energy perspective is something that is important as well. We want to make sure that we control the glare, and something that we see more and more is daylight modeling. So we want to make sure that the light is really penetrating into the building. This large pivot door in this essentially underground apartment makes a huge difference for this occupant, obviously. With the energy performance, the intent is to improve the energy performance. Now, from an operational perspective, we need to reduce the carbon emissions in our buildings. And having more daylight, meaning we don't have to turn the lights off, and that helps. Requirements. In the United States, we comply with ASHRAE 91, in this case 2010 I'm listing here. There's two ways to follow that guideline. It's energy modeling, so the performance path, or the prescriptive path. And most single-family projects follow the prescriptive path, where we know what kind of U values we need, what kind of solar heat gain coefficients we need, and of course the products that Keller Minimal Windows offers there that meets those requirements. Comfort is an important one. It promotes the occupant's productivity, comfort, and well-being. And this is important, and there's requirements as well, but it's important to point that out, particularly in cold climates. If we have the surface of the glass interior deviating further than about 7.2 Fahrenheit from the internal set point in the room, which is typically about 68 Fahrenheit, that creates an uncomfortable draft. And that uncomfortable draft, if we are working, sitting, living close to our sliding doors or windows, that's causing health issues. Now, just a quick update here. How do we enhance the performance of the sliding doors and windows? The glazing layers, single pane, double pane, triple pane. By the way, in Europe, it's about 70 to 80% triple pane use. In the United States, that is really not the case. So there's really room to improve, particularly from a comfort perspective. Moving from a single pane to a double pane, the energy savings is crucial. It's enormous. From a double pane to a triple pane, the energy savings is not as large, but the comfort and potential moisture issues, if we don't go that extra mile might be an issue. Now, of course, we have the spacer between the panes. We want warm edge spacers. When you specify spacers on projects, the industry can provide them. Go away from the stainless steel spacers and use those warm edge spacers. The type of the low E coatings. A low E coating, solar reflective coating, reflecting the solar radiation from the outside, reducing heat gain, and reflecting the long wave thermal radiation from the inside, keeping the heat in the building, obviously. Spacer materials and design, and the sash and the frame. In this case, this is a wood window, but the same is true for an aluminum, a UPVC window. The performance of the window is a total of the glass, the spacer, the frame, and how it's installed. And if I add all those up, I get to an overall U value of my system and window. We use energy modeling to model this, but you could technically calculate that by hand as well. Now let's dive into minimalistic system versus more standard systems. What we can see here is a minimalistic system. And we're going to zoom in a little bit here. This is a more standard system, aluminum as well. This is UPVC, and this is wood window. Now, if we like wood, we want to see it, but of course this is not really minimalistic. What we consider minimalistic is the profiles here at about 26 millimeters in the vertical, in the horizontal about 25 millimeters. There's new systems now, for instance the Keller next slider generation, where we only have a 5 millimeter sideline here on the vertical lower end. So we want to be flush with the floor. We want that seamless freeway system, also to avoid trip hazards. And trip hazards, particularly in commercial projects or restaurants, hotels, it's actually a big liability issue. Now the systems itself, in this case what we're looking at is a system that has the roller in the sliding element. They're stainless steel, so they don't corrode, something that the company learned over many years. There is a brush or a gasket right in front of it that whenever we're sliding the system, we are cleaning the sliding rail, and that is very important considering the maintenance of these kind of system versus having the rolls in the bottom half where hairs and also dust can settle, and we may have an issue cleaning those. Now those systems are thermally broken, and then obviously for project teams there's cross sections that can be provided. Thermally broken system, the drainage, unlike most systems in the United States, is already included. So we're not just putting a drainage sill down, plate down, and screwing the system through. the top. No, there is a drainage system included. We're not going through the top. We're coming from the side so that we're not penetrating through the system, so it stays really watertight. Thermally broken, something very important. We don't want moisture issues. We don't want frost, so freezing in the system. So this is obviously something that in this case Keller really focused on to make sure that we have a good thermal performance. They're a freeway system, so we can kind of see how we move the material throughout the sliding tracks. There's no trip hazard here. We have the corner post free, so that's really what I like to see. Looking at different materials, this is aluminum. Aluminum is highly conductive, but when you look at the double pane system, we're getting to a 0.19 BTU per square foot Fahrenheit hour and 1.1 watts per square meter Kelvin. Triple pane going all the way down to 0.17. So we're pretty much to passive standard, which is really amazing, exciting. And obviously we see the isotherm here. It's very cold outside, warm inside, and we turn this around, it will work as well. We see that the system is thermally broken and works really well. So although it's a conductive material, if it's used and designed in the right way, and a lot of engineering went into this, it is highly high performing. Another alternative here, we're looking at a steel system. In this case, this is thermally broken as well. Perhaps in this case, the one that we're showing not performing quite as well, 0.28 BTU per square foot Fahrenheit. Other systems as wood in general, of course, is a not highly conductive material. It's a good insulator, so performing really well. And if we want to see that wood have that warm feel, then that is great. If we want a very slim, minimalistic system, it may not be the way to go. But the performance is really good at 0.11 BTU. So that's definitely something to consider. And then we have UPVC. The performances, those are thermally broken as well. Manufactured by UPVC. Now, of course, they're in this case not as thin, but well performing. Going back to aluminum, focusing on the topic of today's presentation, the heights are available up to 236 inch. Movable units, 129 square foot. Fixed units, 193 square foot. And a different system, as I mentioned originally, double, triple, pivot, curved, highlight, fixed. And these are systems that we see across the bench with different manufacturers that are available in the market. And so I just want to show you some examples here, how they're used in a double IG project, a triple IG project. Obviously there we have a bit more reflectivity. We have those two low E coatings in that makeup. We have more glass, more reflection, so the appearance a bit different. The pivot door in this case here as well, and curved as well, something we see more and more. And then there's fixed elements as well that can be used with this material, aluminum. Now, when we design buildings, there's environmental factors we need to consider. We need to consider the solar azimuth, the elevation. We look at how does the sun moves around the building. When we work with a lot of glass in a building, this is something we have to consider. We have to consider what climate we're in, and how are we shading this building is something important as well. Cloud cover, of course, for me being in Houston, Texas, there's a lot of direct sunlight. Being in Las Vegas as well, this may be a little bit different being in the Northeast where we have a lot more cloud coverage. Now, existing shading we want to use, but we also want to use high performance materials. In this case, glazing with well-performing solar heat gain coefficient, which for the newer architects that may not have heard of this, 100% of solar radiation hitting the surface of the glass. Some is transmitted directly, some is absorbed by the glass, and then by radiation penetrated into the building. Solar heat gain coefficient is the percentage of that 100% getting into the indoors. And then there's the window reveal depth that can be considered, the window frame dimension, and of course the shading and the overhang. Something when we work with these large sliding doors is something extremely important to consider how we mitigate heat gain and heat loss. This is a standard IGU. We don't have to go more into detail, but of course we can also use switchable class types that become more and more popular, particularly in hot climates where we want to reduce the solar heat gain coefficient all the way down to 15% on a push of a button, and then move them all the way up to 35-40% if we want that passive heat gain. But then also, when the solar heat gain coefficient goes up, the light goes up. So it allows us really to change that visible light we're getting into the building. Shading, types, materials, position, color, something we need to consider really quick. The shading factor. The shading factor essentially is the total energy transmittance, all the energy that goes to the indoors divided by the solar heat gain coefficient of the glazing, essentially, and that's the shading factor. That's what we're talking about. And when we talk about shading, it's important to consider, where do we shade? In almost all projects in the United States, unfortunately, shading is done inside. It's not the case in Europe. We have shading on the outside. In this case, we're happy. We have a smiley face. We have the shading on the outside, which heats up. There's a chimney, a wide enough space between the shading and the glazing. The heat moves up, and it has nice room to move. In this case, we're too close to the glazing. It heats up. It moves through, but there's going to be some radiation that goes through the glazing into the building, and it heats up the building. Then we have inside shading, which we see a lot of cases in the United States. If we had the opportunity to use this heat through an energy recovery ventilator or something, that would be great. But of course, we don't have that. Typically, we just have a standard blind. The heat just goes up, it rises, it goes into the room, and now we have to cool. We get these peak loads. These peak loads causing us these high cool air conditioning systems that are expensive, and they use a lot of energy. We can go further back, it gets even worse, so we really want to consider that. Now, this looks like an overly complicated graph, but this is a really cool study that looked into the total solar reflectance of shading and the impact to the interior room temperature. We have a total solar radiation of 5% in the shading and 29%. These two we're comparing, and what we really see is that the internal room temperature decreases by 3 degrees Celsius, by 5 degrees Fahrenheit, if we have that higher reflective shading material being used. Now, that is a lot. When we look at our energy bills, this actually makes a huge difference down the road. Also, the color makes a difference. I always thought that white would be the most reflecting color, something to use if I want to keep heat out. It is actually the RAL 9006, sort of this bluish color that has the best solar reflective values. And then, just to finish this presentation, there are a lot of trusted partners in the United States and Canada that have realized a lot of projects, particularly in this case, Keller Minimal Windows, who's supporting this AIA accredited presentation. And I just wanted to give a feel for the kind of projects Keller works on. And this is a short video giving you an idea on a project in LA, which is quite interesting. Keller realized a 6-track sliding system, which is unheard of, all motorized, and so really pushing the envelope to something that may not have been possible in the past. So we see here the tracks, 6 tracks, all motorized. A beautiful project in LA. Okay, with this, if you're interested, there's more presentations on more technical details, diving into different systems, and we're happy to set something up with you. For today, I want to thank you for joining, and I hope to see you again soon. Thank you so much.